Hi and good evening to Associate Professor Dr. Lau Kahin. My name Muhammad Syahiful bin Abu Bakar. Today I would like to present on video assignment of SQC 7013 Chemometric on design of experiment. The title of the assignment is The Screening of Factors Influencing Copper-2 Extraction by Soybean Oil-Based Organic Solvents Using Fractional Factory Design. There are 6 steps on the experimenting process, whereby the first step is to define the study objective. Second, describe the experimental subject. Third, select the process variables. Fourth, select an experimental design. Fifth, execute the design and collect the data. And finally, we have to analyze the data. Based on the study, the objective is to identify the significant factor that give large effects on the efficiency of copper-2 extraction from aqueous solution by soybean oil-based organic solvent. The process variables that involved in this experiment is the sample itself is soybean, response, the percentage extraction of copper-2, and there are 6 factors in this study. The first is mixing time, second di-2-ethyl acyl phosphoric acid concentration, third is the organic to aqueous phase ratio OA, fourth the equilibrium pH, fifth sodium sulfate concentration, and the last one is tributyl phosphate concentration. The selection of the experimental design. The experiment used fractional factorial design through the power of k minus 1 design, whereby the 6th factor is minus with 1 and we can get the 32 runs instead of 128 runs. And here is the postulated model: y equal to b naught plus b1 s1 plus b12 s1 s2. And we choose this design because of the number of factor is more than 4, and the purpose is for the screening study. It is suitable for screening study, and also the design is require fewer runs and enable estimation some main effect and interaction, and can be used in sequential experimentation. Okay, this is the 5 assumptions that we need to concern when we're going to interpret the data from the fractional factorial design. The most important thing is the third and higher order interaction are not significant, and the next assumption is the effect of heredity principle. If there are two contrasts are weak, the interaction are weak as well. This is the design metric for the 6 minus 1 fractional factorial design and average percentage extraction measured by using the JMP software. And on the right side is the table of the factor and level applied in this design, whereby there are 2 levels, high and low. And basically, this design is the resolution 4, whereby the main effect are not aliased with other main effect or two-factor interaction, and two-factor interaction can be aliased with other two-factor or higher interaction. This is the screening for percentage extraction of copper-2. Based on the screening, we can see that there are 3 terms that greatly impact the percentage of the extraction. From here, we can see that the individual p-value for these 3 terms is less than 0.005, and the third and higher order interaction are not significant in this resolution 4. On the right side is the half normal plot, whereby we use this plot to determine which term is greatly important in affect the percentage of the extraction. From here, we can see that 2 main effect and 1 second order interaction influence the percentage extraction significantly. This is the Pareto chart to evaluate the main effect and the second order interaction. The vertical line in the Pareto chart indicate the minimum statistically significant effect magnitude for 5% significant level, while the horizontal column length are proportional to the degree of significance for each effect. Any effect or interaction that exceed the vertical line is considered significant. This is the fit least square model for the main effect plot. Based on this model, we can see that this 3 term is very important in this experiment. This is the last fit least square model for the main effect and the interaction. Based on the summary of fit and ANOVA and also the parameter estimate, the 3 terms here is very important in affecting the percentage of the extraction. Thank you.